So here we are going to explore or find the higher derivative. And we have a quick example on that. Example, find the following derivatives. So here is the function given in part A, and we are asked to find the third derivative. So in part A, we are asked to find the third derivative. The function given is y equal to 5x to the 5 minus x squared plus 3x minus 12. That's our function. This is the explicit function because you have y by itself already. So if you want to find the first derivative, it will be dy over dx. And the first derivative will be, if you want to find the derivative of 5x to the 5, you'll use the power rule. You'll bring that 5 down. So 5 times 5, 25. You reduce the power by 1. Then minus, if you want to find the derivative of this one, derivative of x squared, you'll bring that 2 down and reduce the power by 1. And for this one, 3 is a constant multiple. So 3 and derivative of x is 1. Then minus, derivative of that constant is 0. So that's my first derivative. Dy over dx is the first derivative. Here we are looking for a higher derivative. And in part A, we are asked to find the third derivative. That means we have to derive this, or we have to find the derivative 2 more times. So this implies the second derivative. This is how we write second derivative. D squared y over dx squared. That's second derivative. Equal to, let's find the derivative again. This one, we use the power rule. Bring that 4 down. So 4 times 25 will be 100. And reduce the power by 1. Minus 2 is a constant. Derivative of x is 1 with respect to x. So just that. 3 times 1 is 3. Minus 0, that's also 3. And derivative of 3 or constant is 0. So we don't need to write that 0. So this is the second derivative. Second derivative is 100x cubed minus 2. But we are asked to find third derivative, so we'll go one more time. This is how we write third derivative, d3y over dx cubed, which is equal to, now we are differentiating with respect to x. So we bring that power down. So 3 times 100, that'll be 300x squared because we are reducing the power by 1. 300x squared. 2 is a constant. Derivative of constant is 0, so I don't need that. So this is the derivative. This is the third derivative of the function given in part A. D cubed y over dx cubed equal to 300x squared. Okay, part B now. We have to find the second derivative of that function. In part B, the function given is x squared plus y squared equal to 25. This is the implicit function. When I say implicit function, you cannot solve y by itself easily. So for this type of function, we do the implicit differentiation, which is d over dx of x squared, then d over dx of y squared, and then we have d over dx of 25. Derivative of x squared, now you know that it is 2x. Derivative of y squared is 2y dy over dx, because you are differentiating y with respect to x, equal to derivative of 25 is 0. I am looking for dy over dx, so I'm going to move this 2x to the other side. So it will be 2y times dy over dx equal to, if I subtract 2x on both sides, it will be minus 2x. Now I want to find dy over dx by itself, so I'm going to divide on both sides by 2y. So if I divide here by 2y and divide here by 2y, 2y gets cancelled on the left hand side. And I get dy over dx is equal to negative 2 and 2 cancel, negative x over y. So that is the first derivative. We are asked to find the second derivative, but this is the first derivative. So after we have the first derivative here, let's find the second derivative. So the second derivative will be, let me begin writing from here. If I differentiate this again, it will be the second derivative, which is d squared y over dx squared, that is a notation, equal to this negative as it is. Now this is a quotient. So we have to use the quotient rule to find the derivative. And the quotient rule says denominator, which is y, multiplied to the derivative of numerator, derivative of x is 1, minus the numerator, which is x, times the derivative of denominator. Denominator is y, so the derivative of y is dy over dx, divided by the square of the denominator. There is y in the denominator. When you square it, it will be y squared. Now let's see what we get. This is equal to, if I distribute this negative sign, it will be minus y, and then negative and the negative, that will be positive x. Okay, negative and negative is positive x. And here I have dy over dx. I want to find the second derivative, but I already know what is dy over dx. You can look here, dy over dx is negative x over y. So in place of dy over dx, I can use the value from there, which is negative x over y. And in the denominator, we have a y squared. And in order to simplify a complex fraction like this, there is y in the denominator. What I'm going to do is I'm going to multiply both numerator and denominator by a y. I'm multiplying here by y and multiplying here by y to remove this y from here. So meaning of that is this. Let's see, what is that? This is quite interesting. D squared y over dx squared is equal to, now this y multiplied to this one, negative y, is negative y squared. And then if I multiply here, this one is positive and here is a negative, plus times minus, that is minus. And then x times x, x squared. And in the denominator, there is a y. So if I multiply by y in the numerator, that y and this y will get cancelled. So we are done with the numerator. In the denominator, we have y times y squared, which is y cubed. So that is equal to, here we have negative and negative. So if I factor that negative out, if I factor the negative out, it will be x squared plus y squared. But what we know is from the question, if you look there, x squared plus y squared is 25. So if I factor the negative out, it will be x squared plus y squared, which is 25. Over in the denominator, we have y cubed. So that is the second derivative of the function x squared plus y squared equal to 25. Now in part C, we have y equal to e to the x multiplied to 2x plus 1. This is the product of two functions. So we are going to use the product rule here. So dy over dx, the first derivative is equal to first function, which is e to the x, multiplied with the derivative of second. Derivative of 2x plus 1 is 2, plus the second function, which is 2x plus 1, multiplied with the derivative of first, and the derivative of first is e to the x. Derivative of e to the x is e to the x, which is equal to, over here in these two, here is e to the x, here is e to the x. That's a common factor. We can factor it out. And inside the parenthesis here, we have 2x plus 1 remaining, and here is 2 remaining. So 2x plus 1 plus 2 is 2x plus 3. That is the first derivative. We have to find the second derivative. So we have to find the third derivative. So let's go to the second first. Second derivative, d squared y over dx squared is equal to, now first derivative is in the form of product. So we'll use the product rule again. And it says the first function e to the x multiplied with the derivative of second, derivative of 2x plus 3 is 2, plus second function 2x plus 3 multiplied with the derivative of first, derivative of e to the x is e to the x. Again, if we factor e to the x from these two, e to the x out, and here we are remaining with 2x plus 3 plus 2, which is 2x plus 5. That is our second derivative, e to the x multiplied to 2x plus 5. We need the third derivative, so we'll go one more time, which is d cubed y over dx cubed. It's still a product, so we'll use the product rule. First function e to the x multiplied to the derivative of second, derivative of 2x plus 5 is 2, plus second function 2x plus 5, multiplied to the derivative of first, derivative of e to the x is e to the x. So this is equal to, again, we can factor this e to the x out. Then we get 2 plus 2x plus 5, which is 2x plus 7. So that is the third derivative of the function y equal to e to the x times 2x plus 1.